In this program, we are asked to add two 8-bit values stored in memory location 2000H and 2001H and then store the result in 3000H. We've already done this program in our previous video. If you haven't checked it out, go to our playlist Microprocessor 8085 and then go to that video. The additional part in this question is, if a carry is generated during the addition of these two values, then store the carry in 4000H. Now this program includes a conditional operation too. It's not always guaranteed that a carry is generated during the addition of these two numbers, but if it is, then we have to store the carry in 4000H. Let's proceed with how we would do this. Again, the steps are the same that we did earlier. In register A, we would load the value available in memory location 2000H. Then we would move this value or copy this value to another register B2. We would then load our register or accumulator with the value from memory 2001H. Then we would add these values, right? In the previous question, we simply stored our result, but in this case, we do store our result to memory location 3000H, but in addition to that, we check if a carry is generated, check if carry occurs. If yes, then we store our carry in memory location 4000H. If not, then we leave the program as it is. Now this program typically again this program includes a conditional statement. So we'll do our program accordingly. Let's proceed with the code. We will load our first memory value into accumulator using direct addressing mode. Move this to another register using register addressing mode. Again load the second value. Now we can simply add our result or add our values from accumulator A and B. Now we know that this particular result is going to be stored in accumulator. As I talked in my previous video of flag register, this is a data manipulation operation, which means this particular instruction set or the execution of this instruction will result to update a flag register. Now whenever a carry is generated, now our carry flag is set to 1. So we need to check whether our carry flag is set or reset here. We'll do either of the two cases. We'll basically work with the set case. Okay, so what we're going to do is we're going to write jump on carry, and then we move our program or break our program to someplace else. If this is not executed, what typically happens is our result is stored in 4000H and our program terminates. But if there is a carry, then our program will directly jump to this part from here, and then we are going to first store our result, and since we want to save our carry and that particular carry is present here in our carry flag, we always know that whenever we are adding two different binary numbers, the maximum binary value used during addition is 1 1 and the minimum is 0 0. So in case of 0 0 the flag is not set, but in case of 1 1 the flag is set, and the maximum value of the flag is always 1. So what we can do is we can directly move oh sorry, I should have stored the result in 3000, not 4000. Yeah, so 3000 and the same here 3000. Now I can move a value 01H in my accumulator, and then what I can do is I can store if it's not fit here. Then I move the code up here, so I can store the result of the accumulator or the value in the accumulator in another register called 4000H, and then basically terminate the program. So as you see, there are two conditions. In the first condition, whenever the program execution goes sequentially and the carry is not generated, the program does not jump to this part here. The program simply moves down and then executes this instruction, and then the program is terminated. But if a carry is generated, then the program jumps to this next part. These two lines of code are not executed, and basically we store our result first, and then we store the carry in our designated memory location, and then terminate the program, so that the program does not jump back, and then the execution of this particular line takes place. So this is our program. Now we can run this program in our simulator. Now we'll load our memory locations with two values. Let's say 06, or let's say FFH. This is definitely bound to generate a carry, because the maximum value in case of 8-bit in hexadecimal is FFH, and then we add this to maybe 01H. So first load the first value from 2000H, move this to a register B, load the second value from 2001H, then add these two values to basically compare if a carry is generated or not. If a carry is generated, we redirect our program to someplace else. You can give any string tags here. It should be a string. It should not contain any space or any other symbols. It can just be a tag. Let's say tag for now. If this does not work, or if this condition is not satisfied, then we want to store our result in 3000H and then terminate our program, right? But if this condition is satisfied, then we still want to store our result in 3000H. We want to take our carry and then store it in accumulator, and then store the carry part in 4000H, and then terminate the program. Now if we run this code, and if these two values are present, then definitely a carry is going to be generated. Now if we see this, at first FF is being loaded in the accumulator. It's copied to register B. 01 is loaded to accumulator. Now these two values are added here. The result is 00, but as we see, the carry flag is set here. Now since the carry flag is set, the program execution will not go to the 6th line, but instead it will go to 8th line here. See, it goes to the 8th line. In 3000H, the result is stored. The result is 00. So in 3000H, the result is stored. Now we simply need to check if our carry is stored or not. So we move one more line below. Now in accumulator 01 is present, and in 4000H that particular 01 is stored, which means a carry is stored. Now let's change this, or change our values 3000H, or what I can do is I can simply reload the simulator. My program is still there, but my values are not present, or they're reset. Go to 2000. Let's write down two values which now does not generate a carry. Let's say 04 and 06. So 04 plus 06 in hexadecimal is going to be 0A, and no carry will be generated in this particular scenario. Now let's compile this code. The code is compiled. Run this program again. We come to a condition where we want to check if our carry is set or not. This particular arithmetic operation will see that a carry is not generated, so the program cannot go to this 8th line here. It simply has to move down to the 6th line, which it does, and then we check the result 3000 in 3000H. See, 0A is present, and the program simply terminates and then does not go below here. So this is it for this particular question.